Good morning, everyone. This is N. Nagarani. In this video, we are going to talk about colloids and what is the classification of colloids based on various factors. So, before discussing about colloid, we have to know what is a true solution is. A true solution generally consists of two components which are called solute and solvent. Generally, the solute will be dissolved in solvent to prepare a true solution. So, these true solutions are homogeneous in nature and they are containing a mixture of two or more substances which are dissolved in a solvent. Generally, we can use water as a solvent, and the size of the particles, solute particles in the solvent will be less than 1 nanometer or 10 to the power of minus 9 meters in the true solution. So we can take a simple example of true solution is a solution of sugar in water or salt in water, etc. And the particles of a true solution are not visible to naked eye, and we cannot filter these solution through a normal filter papers. But a particles in a true solution do not settle down on standing, and they completely dissolve in the solution. Therefore, they cannot be separated by using a ordinary filtration. Now, moving to colloidal solution, and what is the difference between this true solution and colloidal solution? The true solution is a homogeneous in nature, but colloidal solutions are heterogeneous mixtures, and the particle size of the substances in the solution is in the between of true solutions and suspensions. So the particle size of a colloidal solution is ranges from 1 nanometer to 1000 nanometer. So similar to true solutions, the particles in the colloidal solution cannot be seen with the naked eye, but those particles are large enough to blocked by a parchment paper or by an animal membrane. So the colloidal solutions can be filtered using these parchment papers or by using an animal membrane. So these colloidal solutions are also called as colloids or colloidal systems. These are mixtures in which microscopically dispersed insoluble particles of one substances are suspended in the another substance. So in the true solution, the solute will be dissolved in the solvent, but in the colloidal solution, the colloidal particles are dispersed in the solution or the solvent. So in the true solution, dissolution of the solute will be taking place, but in the colloidal solution dispersion of the particles will be taking place. And next one is a suspension is also a heterogeneous mixture in which the size of the particles will be greater than 1000 nanometers, and the particles can be visible to naked eyes. So here in this diagram we can see the size of the particles in the salt solution or in the true solution is less than 1 nanometer, but in the colloidal solution, here we are taking the example of milk. The size of the particle is 1 to 1000 nanometers, and in the suspension, the size of the particles is more than 1000 nanometers. And here in the picture also we can see the examples of true solutions and colloidal solution. In the true solution, the size of the particles is very less, that is less than 1 nanometer. In the colloidal solution, the size of the particle is 1 to 1000 nanometers, and in the suspensions, the size of the particles will be greater than 1000 nanometers. So here this sugar solution and salt solution is the example of true solution, and this is the example of colloidal solution. And we can take the examples of suspension as vinegar or sand in water, etc. So these are the definitions of true solutions, colloids, and suspensions. Now the classification of colloids. So, based on various factors, the colloids are classified into four types. The first factor is depending on the physical states. So, before discussing about the types of colloids, we have to know two terms which we will use in colloids, which are called dispersed phase and dispersion medium. So here a colloid is a mixture in which one substance which has fine particles mixed into the another substance. So here the substances which are dispersed in the solution are called as dispersed phase, and the solution in which the dispersion is taking place is called as dispersion medium. And this colloidal solution is also called as colloidal dispersion because here the dispersion of the particles will be taking place, and the particles do not mix or settle down in the solution. So they are dispersed in the solution. So in this picture we can see the colloidal particles, the substance which are dispersing is called as dispersed phase, and the solution in which the dispersion is taking place is called as dispersion medium. So, based on the physical state of a dispersed phase and dispersion medium, the colloids are classified into eight types. So, here in this table, we can see the eight types of colloidal solutions. The first type of colloidal solution is Sol. This Sol will be containing the solid as dispersed phase and the liquid as dispersion medium. So always the amount of dispersion medium will be greater than the dispersed phase. So when the dispersed phase is solid and the dispersion medium is liquid, the type of colloidal solution is called as sol. And the examples of this type of sol is paints, fruit jellies, gels, and dyes. And the second type of solution is emulsion, in which the dispersed phase will be liquid and dispersion medium will be liquid only. In this type, the examples are mayonnaise and milk, salad, cream, etc. The third type of solution is foam. In this foam, the dispersed phase is gas and the dispersion medium is liquid. The examples of this type of solution is beer froth, soap suds, whipped cream, etc. And fourth type of colloidal solution is solid sol. In this, the dispersed phase is solid and the dispersion medium is also a solid. The examples of this type of colloidal solution is alloys, gemstones, ruby glass, etc. And next one is when the dispersed phase is liquid and the dispersion medium is solid. The type of colloidal solution is called solid emulsion, and the examples are butter, cheese. And next one is solid foam. In this, the dispersed phase is gas and the dispersion medium is solid. So the type of colloidal solution is called solid foam, and the examples are pumice, marshmallow, meringue, etc. And next one is when the dispersed phase is solid and the dispersion medium is a gas, the colloidal solution is called solid aerosol. And the examples are smoke, dust in air, bacteria in air, etc. Last type of colloidal solution is liquid aerosol, in which the dispersed phase is liquid and the dispersion medium is gas. The example of this type of aerosol is fog, mist, clouds, sprays, etc. So in this picture, we can see the examples of different types of colloidal solution: foam, milk, smoke, detergents, gel, blood, paint, cosmetics, body creams, bread, toothpaste, ice cream, yogurt, beer, this smoke, fog, mist, jellies, pumic stone, whipped cream. All these are the examples of different types of colloidal solutions. Next factor is based on the interaction between the two components, that is based on the interaction between dispersed phase and dispersion medium. Perrin and Freundlich classified the colloids into two types: Lyophilic colloids and Lyophobic colloids, based on the magnitude of affinity existing between dispersed phase and dispersion medium. Here, when the dispersion medium is water, then the lyophilic colloids are called as hydrophilic colloids, and the lyophobic colloids are called as hydrophobic colloids when the dispersion medium is water. Now let us talk about this lyophilic colloids. So in this type of colloidal system, the dispersed phase has great affinity for the dispersion medium. So there will be strong interaction between the dispersed phase and dispersion medium. So here Leo means liquid and philic means loving. Here these are the solvent loving colloids. They are also known as reversible sols due to their ability to reconstitute on adding dispersion medium after separation. So even after separating the dispersion medium and dispersed phase from the colloidal solution, they can reconstitute on again adding DP and DM. They are quite stable and do not coagulate easily. Coagulate means precipitated. No, they do not coagulate or precipitate easily. And the leophilic sols are highly solvated, and the particles of the dispersed phase are covered by a layer of the dispersion medium, and they have the ability to protect leophobic colloids from the electrolytes. That means the leophilic colloids can protect the leophobic colloids from the coagulation or precipitation when the electrolytes are added, and they form a protective layer around the leophobic particles. Leophilic colloids can be coagulated by adding electrolyte or a suitable solvent. So naturally, the coagulation of the leophilic colloids not do not takes place, but when the electrolyte is added in more quantity or higher quantity, the leophilic colloids can undergo coagulation. The examples of leophilic colloids are all naturally occurring colloids, like gelatin, gum, starch, protein, rubber, etc. And the second type is leophobic colloids. So in this type of colloidal system, the dispersed phase and the dispersion medium will be having less affinity between them. Like the dispersed phase do not have high affinity for the dispersion medium, so the colloid is not readily formed. And this type of colloids are also called as irreversible sols, since they cannot be reconstituted by simply adding dispersion medium after precipitation or coagulation. And they are unstable in nature and can coagulate easily on adding electrolyte, shaking, or heating. Leophobic colloids can be prepared by special methods and require a stabilizing agent. But in the case of leophilic colloids, they can be prepared easily just by mixing dispersion medium and dispersed phase, or by shaking dispersion medium and dispersed phase. But in the case of leophobic colloids, they cannot be prepared easily. We have to use some special methods to prepare this colloids. And the examples of these leophobic colloids are metals and their insoluble compounds such as sulfides, hydroxides, etc. And here in this picture, we can see how the leophilic colloids are protecting the leophobic particles from the coagulation. This is the second type of colloidal solution. The third factor is depending on the electric charge on the dispersed phase. So depending on this charge of the colloidal solution, these are classified into two types again. One is positive colloid and second one is negative colloid. And the process of adsorption of specific charged particles on dispersed phase particles play an important role in contributing towards the charge of the colloids. So first type is positive colloid. Here the dispersed phase will carries positive charge, and the examples are ferric hydroxide, methylene blue, titanium oxide sol, etc. And the second type is negative colloid. In this, the dispersed phase carries a positive charge, negative charge. The examples are arsenic sulfide, ferrous sulfide, congo red, and eosin distuffs. And based on the fourth factor, the again the colloids are classified into two types. So the fourth factor is chemical nature. So based on chemical nature, the colloidal solutions are also classified into two types. One is inorganic colloids and organic colloids. So depends on the chemical composition. The inorganic colloid may be metal salts like silver, arum, copper, or non-metal salts like graphite, sulfur, and oxides or sulfides and hydroxides of the metals. The organic colloids may be homopolar like rubber in benzene, aqueous salts like starch, glycogen, and heteropolar salts like proteins, soap in water. So this is about colloid and classification of colloids. In the next video, we are going to talk about properties of colloids and applications of colloids. Thank you.